Okay, binomial expansion and binomial probability. This is only for GCSE stats. Okay, now this is technically is an A-level subject, but what they've done, they've really taken all the hard stuff out, and you just need the basics for your GCSE stats. Now, if you go on the internet and you search up binomial expansion, chances are you're probably going to get the A-level stuff, which is just going to be too hard. But in this longer video, I'm going to explain where these numbers come from, so you understand the concept, and I'm just going to go on just to explain what you need to know to actually answer a question in GCSE stats. Right, so first bits first, have a look at this triangle, tell me what you notice. Okay, pause the video, because there's quite a few patterns. Oh, right, the obvious pattern should be, if you take like this number here, 10, that's made up of this 4 here, and that's 6 there. Okay, and it works all the way around here. So let's say it's 45, that's your 9, plus your 36. Okay, and it works all the way down. Okay, and this is Pascal's triangle. Okay, now there are other patterns here. Okay, let's extend to the first one. If I pick any number like 28, okay, I add all of these numbers up, and I get 28. Okay, there's other ones as well. If you look at like your third row, okay, if you add these two up to get that number squared. Okay, so 3 plus 1 is 4, 2 squared is 4. So this one here, 10 plus 15 is 25, which happens to be 5 squared. Okay. You've got your triangle numbers there, which are actually nicely presented in the diagonal. Okay. And there's a few others. Right, something else you need to do. I want you to expand all these, see if you notice anything. The only key thing that I really want you to remember is this one here, x plus a squared, is actually going to be x plus a multiplied by x plus a. Okay, and the ones in the blue box you might actually be asked in GCSE maths, but not in GCSE stats. Go, expand them all. Right, pause the video. What you should really get is these are your answers. Right, and if you get confused, anything to power 0 is 1. Yeah, anything to power 1 stays the same. 2 is what you did, and so on. Now have a look at this and see what you notice. Should be a couple of things going on. First of all, if you think of the power of a, okay, let's talk about one. It starts at the same power of this, and it goes down. So a to power 4, a to power 3, a to power 2, a to power 1, and technically here there's a to power 0 at the end. Okay, and if you talk about your b's, your b's do the opposite. So technically here there's a b to the power 0, and then that's b to the power 1, b squared, b cubed, and b to the power 4. And it works for each row. Okay. The second thing you should notice, if you look at your coefficients, the 1, 1, the 1, 2, 1, that's the same as your Pascal's triangle that we just dealt with. So inevitably what this means is I can use a combination of the Pascal's triangle, yeah, to expand these. So if I've got something like, here you go, just a bit more of Pascal's triangle. Okay, so if it's squared, I look at my third row, because my first row is to power 0. Now my coefficients can be 1, 2, 1, just like in the triangle. Now my coefficients, here I'll start off as q squared, q to power 1, q to power 0, and then p, I've got p to power 0, p to power 1, p squared. And then here you go. And of course it doesn't matter which way you do it, because these are going to be symmetrical. Let's do another one, p plus q cubed. So again, you look at your triangle, you look at your fourth row, and my coefficient is going to be 1, 3, 3, 1, because it's the same as my triangle. Okay. Here I've done q cubed, q squared, q1, q0. My p goes the opposite one, p to power 0, p to power 1, p to power 2, p to power 3. And then I just simplify the ones, times by 1 don't mean anything. When I do to power of 0, it means 1. So I've got q cubed, 3, because that's my coefficient, q squared p1, which is just p. This one I should have 3q p squared, and then p cubed. Okay. And if you want to do the harder ones, again, I'll look at this row, and I'll substitute all the values in. Okay. Now, don't worry for GCSE stats, you're given the actual row you need to use, and the questions are really nice and straightforward. Right, something's a little bit different. You've got questions here. Okay, so if I'm on one die, what's the probability of getting one successful trial? What's the probability of not being successful? So again, no successful trials. Now, when you try all three of these questions, okay, you probably, the second one and the third question, you probably want to represent it as a tree diagram. Go. This really helps you understand the topic as well. Pause the video. Right, I want to quickly talk you through all of these, yeah, because it's worth understanding. Right, if I'm rolling one die, it's just really straightforward. This is my tree diagram. You don't really need to do it. I'm doing S is successful, F for failure. Okay. So it's just chance of being successful is half, chance of being failing is half. So chance of me, so it's half and half. Nice, straightforward. Okay. Next one, I'm rolling two dice. That should be dice. Just I want an even number, I want an odd number. So I've got all of these options now. So I want to be two successful trials, a successful and a fail and successful, and a fail and a fail. Okay. Each one of them, because it's the same option for the first and the second, it's always a half. Okay. Now this is just the last bit of my tree diagram. Probability of getting two successful trials is just my top one. So it's going to be a quarter. One successful trial. Well, I've actually got two situations where this happens. So I need to be successful and I also need to be unsuccessful. And it's two different ways. So it's actually 2 quarters. I know you can change it down to a half, but I'm going to leave it as 2 quarters just for the time being. And not being successful is clearly going to be 2 fails. Okay, so these are my outcomes. I've got 1 quarter, 2 quarters, and 1 quarter again. Okay, now this is a harder one. But again, you might be asked in GCSE maths, so we've got to cover it. Do your tree diagram. So I've got all of these situations now. Okay, and these are quite hard to draw. Each one's got a half chance of happening again, so you put halves in. I've got an 8 for each one of these events because they're each one likely to happen. Now, the chance of 3 successful trials, I've only got one option for that, which is going to be an 8. 2 successful trials. Now, if you look at this, I've got those 2 and I've got this. Each one of them gives me 2 successful trials and 1 failure. So it's going to be 3 out of 8. Okay. 1 successful trial. Again, I've got 3 times of doing this. It's also 3 out of 8 and no successful trials. So I've got 1 8, 3 8, 3 8, and 1 8. Okay, so I've got all my probabilities here. Have a look at these, see if you notice any patterns. I'm going to help you out. I'm going to put the Pascal's triangle next to it, and there was a reason I was explaining it. Now, if you look at my first event, my numerators correspond to the second row. My third one, this numerators correspond to my third row. And my last bit, my numerators correspond to my fourth row. So I can use Pascal's triangle to work out the numerators of these events. Now my denominators, if you think the chance of the event happening was 1 over 2, that's 2 to the power of 1. This one here, again, the event was 1 over 2, that's 2 to the power of 2. And my denominator here was 2 to the power of 3. So I've got all the information now to work out these events. But these questions, when they're given to you in GCSE stats, are really structured. You're given the line that you need and everything else should be fine. So your notation for this is sometimes